Welcome back to MKE Gadgets. Before we solve today's problem, please support me and subscribe to my channel. I really appreciate it. So today's video is problem solving, which most videos on YouTube are. In a future project, I'm going to add some electronics to my dust collector, so when I turn on any tool, it will turn on a dust collector and open the appropriate blast gate. And part of this system, I'm going to need a solid state relay and an outlet. The solid state relay will take an electrical signal, will turn this outlet on, and my dust collector will be plugged into here. So let's look at all the parts we're going to need today. Outlet, solid state relay we talked about, an electrical enclosure. These solid state relays are notorious for giving off heat. So I have a heat sink that's going to be bolted on here. And all these aluminum fins will help dissipate the heat. I'm going to need an electrical cord, and this was scavenged from my old wash machine. This is 14 gauge, the same gauge as a dust collector. You want to make sure that this cord is heavier or equal to that of your dust collector. Using some bell wire left over from installing the garage door recently, and that's going to send a signal to activate the relay. Also going to need some connectors that screw into electrical box, and this is where the cord goes through. By many names. One is a wire gland. They have different diameter holes, but you want to get the threads for your electrical box. Mine is a 1/2 inch. The bell wire diameter is much smaller. So you can see the yellow here, I put in an adapter, and that holds this bell wire tight in here so it doesn't get pulled out. All the parts I showed, we're only missing one thing, and that's what we're going to make today. I have a scrap piece of aluminum here, and this is going to be the cover, and that's really today's project. I'm going to cut it in the chop saw, and we're going to take it over to the Bridgeport mill, and we're going to drill a series of holes, mill a pocket that this will fit into, and then mill the outside shape so it'll go on top of our electrical box. First thing we got to do is go to the chop saw and cut this a little bit big. So here we are at the chop saw. I'm going to cut a little bit left to the right line. Now I know what you're saying. Can you cut aluminum on a chop saw? Yes, if it's carbide tooth and the material's not too thick. This is going to kick up aluminum chips here, so I'm going to put a piece of particle board to cover that. Hopefully this will keep all aluminum chips from flying everywhere. Well, it still made a mess, but I think it helped a bit. I have one more cut here, and then we'll drill a few holes. So here we are at the Bridgeport mill, and I cut off the other side of the aluminum. A piece of particle board that was covering the aluminum while it was being cut is going to be my fixture. The inside line here is the shape of the electrical box. The outside line here, I want to put a couple of screws in to hold this down to the particle board. So we'll put that in there, I'll line it all up, and tighten it up. Now I'm going to drill a few 1/8 inch holes, and that's for this screw here, number 6 by 3/4 long. So I drilled one hole. I'm going to add the first screw, and that will hold the plate from sliding around. Just a couple more screw holes. With 6 screws put in here, this aluminum plate's going to go nowhere, and I can drill into the waste board down below. With the pointy edge of my center finder, I picked up the center of the board. I zero out my X and Y axis. Like most of my projects, I start out with a hand sketch on graph paper. I write down all the dimensions that are critical. And then I take them to Fusion 360. I make a model. And then 3 programs. One for drilling, one for milling the center hole, and one for milling the outside. Here's the electrical box. Before I go any further, I just want to make sure I'm inside the screws, and there's going to be extra material to remove. First program is going to drill holes, and 4 of those are for mounting this electrical box. The other 2 holes are for mounting the solid state relay and for mounting that switch. Then we're going to take the screws that are holding the outside and we're going to put them into the new holes that we make. First we're going to use a center drill and we're going to drill all pilot holes. Next we go into number 28 drill and drill all the holes. With all the holes drilled, we're going to just make sure we have the right bolt pattern for a solid state relay. And that goes in there. That looks good. And this is our outlet. And that's going to go right there. We drilled the pilot hole here. Now I want to come with an end mill and make that bigger. The biggest end mill I have is 3/4 of an inch, 2 flute. So we're going to come over here and we're going to mill this straight down. In Fusion 360, I programmed this to mill a pocket out here. But before we do that, I want to add some more screws here to hold this aluminum down a little flatter. Screws I first put in, and I moved them to the new holes I made. So when I mill out this pocket, it holds it tight. So according to our drawing, this hole that we're going to mill out now is 1 3/8 in diameter. And that's for the receptacle. I'm using a 1/2 inch 2 flute high-speed end mill. I'm going to come down and just do a little scratch cut and check the diameter before we go any farther. The diameter of the outlet is 1.365. And this should be 1.375, giving us a little extra room. It says 1.372. I don't think I got all the way in there in the corner of that groove. I'm going to call that good. At least I know it's not real big or real small. It says 1.372. And let's try the outlet in there because that's more important. And the outlet fits in there perfect. Now I'm going to take these 2 screws off so we can mill the outside. I'm just going to do a scratch cut on the outside just to make sure our dimensions are right. So I just did a scratch cut, and let's check our sizes. And that's going to be perfect. We did our scratch cut, size is good. Now we're going to machine the rest of this material off. And that's not going to work. Right away we got a lot of chips in there. All right, my depth of cut was too deep. and my feed was too slow. My RPMs were not high enough, and it just galled up. I can't run coolant down here because I have no way to contain it. So I manually went around and I removed most of the material, and now we're just going to run the program, and it's just going to go around and clean up here a little bit. Hopefully this works. Fits perfect. All I gotta do is take it off of here, deburr it, clean it up, and a quick engine turn. Well, here we go, the finished product. We got an outlet here for our shop vac. Inside here is our solid state relay with a heatsink on top. Now this new cover is aluminum, and that too will act somewhat as a heatsink. Next time I have black in the printer, I'll reprint one of these. And that ain't going, and that's not going nowhere. This is MKE Gadgets. I hope you enjoyed today's video of making a custom electrical cover. Please support my channel by subscribing. Thanks, we'll see you tomorrow.